small letter r or the Greek letter rho is the number that tells us if there is actually a relationship between two variables and tells us the strength of that relationship. Alright, and we know that it is given by the formula that follows covariance of the two variables, usually x and y, over the standard deviation of x and the standard deviation of y, the product of that and the square root of the product. Alright, so that we have the covariance of x and y becomes summation of x minus x bar, close bracket, y minus y bar, all over the square root of summation of x minus x bar all squared now, and summation of y minus y bar all squared. Okay, so we know that rho is equal to this, and I did establish in the last video of introducing, where I introduced correlation, coefficient, correlation, introduction to correlation. I did tell you that this formula is the same as the same formula n summation x y minus summation x summation y all over the square root of n summation x squared minus summation x all squared, close bracket, then multiplied by, we're going to repeat the same thing for y, but we'll basically change the x to y. So we have n summation y squared minus summation y all squared, close bracket. So how is this formula equal to this? That is what we want to prove. So let's prove that this formula is equal to this. Alright, so I'm going to be cleaning this segment. We know that the numerator is this. So we start from the numerator. Let's make this numerator equal to this. The numerator, abbreviated as num here, is summation of x minus x bar, as the covariance of x and y. Alright, so what do we do here? Let's expand this. It becomes y times this. We have summation is outside the bracket. Y times this, we have summation xy. Y times this becomes x y bar. X times this, x bar times this becomes minus y x bar. And minus times minus gives plus. X bar times y bar gives x bar y bar. Alright, so before we continue, we should have a few things at the back of our mind. We know that x bar is summation x over n. Like from, you remember mean, what mean actually means is the summation of all the observations over how many observations you actually have. So that from here we can derive that summation of x is equal to what? Nx bar, right? By cross multiplication. So that we have the same for y bar equals summation of y over n, and the same will apply, so that summation of y will be equal to n y bar. And of course, also know that summation of x bar is equal to n x bar. Alright? And okay, these are basically the constants you should know, or the relationships rather that you should know. So these are relationships that you should know offhand. This and this. So this one belongs to y, and this one belongs to x. Okay. So having established this, we can further now express this by distribute this summation for every guy in the brackets. Let's distribute that so that we have summation of xy, minus, we distribute this, we have summation of x y bar minus y x bar plus x bar, summation of y x bar plus summation of. So we have summation of xy minus this. Remember that summation x is n x bar. So we have n x bar, then dot y bar, minus summation y on the other hand is ny bar. So that we have ny bar x bar plus summation x bar y bar. Alright, and we already know that so this minus this becomes, we have summation xy becomes minus 2nx bar y bar. Okay, so that we have this. Remember that summation x bar or summation y bar, either way, means nx bar. So that we have summation x bar, that will be nx bar y bar. So basically are the same now. Then it becomes summation xy minus plus this gives us minus 1, so that we have minus x bar y bar. So that this becomes summation xy minus summation x bar, and summation x bar is, x bar rather is summation x over n. So that will be dot summation x over n, and y bar is summation y over n. Alright, so that one n takes care of n. So we have summation xy minus xy dot xy, summation x dot summation y over n. So here, to make it look exactly like this form, we can multiply, make this n, we can multiply through by the n, so that it becomes n summation x bar minus summation x dot summation y. So that if n multiplies through, this guy is going to multiply n and give us xy, and if n multiplies n is going to cancel n, then you're left with this. So this is the numerator. Alright. So then the denominator. Now for the denominator, we are going to be doing we are going to be solving for only the x. Why? Because the formula for the denominator says summation of x minus x bar all squared. So definitely, and summation of y minus y bar all squared, then with the square root. So it definitely means that since x and y take the same form here, so whatever expression we are able to derive for x is the same expression that will go for y. Alright, so we have summation, we'll be solving for only x, summation of x minus x bar all squared. So that I express this in full, I have summation of x minus x bar and summation of x minus x bar. So that I have summation of x by x squared, minus x by this x bar, minus this, that will be minus x bar, minus this, that will be plus x bar all squared. Okay, so we know that we can, let's use the summation to open the bracket. Recall this to a bracket. So if the summation opens the bracket, we have x summation x squared minus summation x bar minus summation x bar plus summation x squared x bar whole squared. Okay, so recall that summation x here was nx bar, right? So we have summation x squared minus nx bar x bar. This gave us nx bar from here, so x bar. Then minus, the same applies to this, so that we have Summation x is what? N x bar. So n x bar, then x bar, which was there initially, plus the other guy, this guy, summation x bar. From here we know that summation x bar is n x bar. So if summation x bar is n x bar, then this can be n x bar squared. Okay, so that this becomes summation of x squared minus, so this becomes minus 2n x bar all squared, because when x bars multiply each other, they give x bar squared, then plus n x bar squared. So that we have, so this look alike, right? So we have summation of x squared minus this plus this gives n x bar whole squared. So now we have summation of x squared minus n, then x bar. What is x bar? X bar is basically the mean of x, which is summation x over n. So we have summation of x over n all squared. I hope that is clear. So I'm transferring this here so that we have summation of x squared minus n summation of x. Now we can x squared means summation of x over n dot summation of x over n. So I've expressed this bracket in full. Alright, so that we have n can take care of n here. So that we have summation of x squared minus summation of x over n. Alright, using the same principle there as we use there, this guy can come here. I mean, we can multiply through by n so that this guy, leaves the denominator, so that we have n summation x squared minus summation x. Alright, summation x by summation x will give us summation x squared. So there is x squared here, and this becomes the expression for this. This becomes the new expression for this. Alright, so we'll have, so we can now use the same expression for y, so that if it were y summation of y minus y bar all squared is equal to, using the same expression, it will be summation n summation of y squared minus summation of y all squared. So notice this is now equal to this, and this is now equal to this, so that we have our expression to be n summation xy minus summation x summation y separately all over the square root of what we had here, n summation x squared minus summation of x all squared, then all into the bracket, then we repeat the same value, nx, the same expression rather, minus summation of y all squared, and close the bracket, summation of y all squared. Alright, so that is the proof for the fact that this equation, Pearson correlation coefficient equation, are similar. Alright, thanks for watching this video till the end. Do well to subscribe to the channel if you have not already. God bless you.